Hello dear learner, in this lecture I am going to teach you the how you uh, deal the different situation while graph is given. So here I am giving you different type of situation and you have to read it and then you must uh, take the information which is hidden in the graph. So first of all, I am giving you impossible situation that cannot be possible in the sense of real world. In the first graph, this is BT graph. Graph is like this. You already know that nobody have two velocities at the same time, isn't it? It means you never have two speed or two velocity or two position or two acceleration at the same time. That's why, let us say this at this time, at this point of time, point of instant, I have three velocities. One is this, one is this, and one is this. That's why this graph is not possible. In the second graph, it is also not possible because at the same time we have two positions. Have you got my point? Now in the third situation, I have taken negative time. So I never thought about negative time, and you also never thought about it. Actually, negative time has no concept at all in science. That's why this situation is also not possible. In the same way, here also there is negative time. And in this graph, as we already thought about it, that for a point of instant, there should not be two speed or two velocity or two acceleration or two positions. In this graph, length is decreases from this point to this, means this time to this, and then increases up to this. So first length it is increases from start to that point, that time, and then during this interval length is decreases, and after that increases. I never think that length should be decreased if a body is in motion, because length is a scalar quantity and length is never negative. Its minimum value must be 0, but after that it must increase. Whether you go on in the same direction or opposite, but length must be increased if you are in motion. That's why in any case length cannot be decreased. So it is also not possible. In the same way, we can say that negative time has no meaning at all. So I have given you some impossible situation, and I have also told you that why these graphs show the impossible situation. Now the next example I give you, when the graph has parallel lines, whether they are parallel to x or y axis. What do you mean by that? I took ST graph and the graph is parallel to time axis or x-axis. It means it has zero slope, and it also means that the speed, or you can say velocity, is zero because slope is zero. You also think that if speed is zero, that means the displacement at every time is same. Body never changes its position. That's why its velocity or speed is zero. Means you can say that body is at rest. Have you got my point? So in this situation, we can think that body is at rest or remain at the same position as time passes. Now in this situation, we can think that for a few seconds, for a zero interval of time, let's say this is 1 second. On 1 second, a body has this velocity, its body also has this velocity, this velocity, this velocity. Means for a particular time, body has many velocities. Or you also can say that at the particular instant, body increases its speed very high in no time. This is the case when we accelerate the car or bike or anything. Let's say my bike is at rest here, but when I ride on the bike and start the bike accelerate in a time which is very negligible, then we say that my speed on the speedometer becomes 20 meters per second. But when I am going to ride on the bike, the bike is at rest. But when I rotate my clutch or accelerator, my speedometer read it 20 meters per second. Then you say that initial velocity of my bike is 20 meters per second. You never say that bike is at rest, so you take initial velocity or speed is 0 meters per second. So this situation is in the real sense that we accelerate the bike or decelerate the bike or body in time which have negligible meaning for us. So we can plot the graph of that situation like this. Here slope is undefined or infinity. That means slope increase very large. That means in no time or very very tiny time or negligible time, we have large velocity or speed. Or you can say that the acceleration here is infinite. So if you compare the real situation, that is the meaning. But we always take the velocity when after the acceleration. That means I have already told you the example in which I accelerate the bike from rest in no time and speedometer reads 20 meters per second. That means I take u as 20 meters per second and neglect the bike when it is at rest. That means this is the impossible situation in the real world. Now in the VT graph, when the graph is parallel, so the slope is 0, that means acceleration is 0 here. That means it shows the uniform motion. where as time passes, speed or velocity does not change. It has same value at every point of instant. Now if I plot AT graph, it also gives A is constant when time passes. So it gives the accelerated motion. Accelerated motion with fixed acceleration. Body may have fixed acceleration or variable acceleration, but here the situation is gives the idea of fixed acceleration. So I hope you have understood what are the graphs which are taken here. Now I give you another examples for positive slope. When the graph has positive slope, what do you mean by that? Here I take body starts from some speed. Body here the situation say that initial body has some initial velocity. Means body is not at rest initially, and the body increases its speed because the slope is positive. That means velocity changes positively, that means velocity increases. It also means that v minus u is positive. That means acceleration is positive. That means speed increases, or you also say that speeding up. This situation gives the idea of speeding up. Here A is constant because it is a straight line graph. So this situation is nothing but uniform accelerated motion. Uniform accelerated motion. Have you got my point? Where initial velocity is not zero. Now in this situation, time is not zero here. Means body waits and then goes in motion. So some observer counts the motion by his watch, and let's say watch reads now here 2 o'clock, but a biker is still at rest. After 5 minutes, means 2 o'clock 5 minutes, the biker starts his bike. So this graph gives the same situation as I have told you. So the body, let's say it is 2 seconds or 5 seconds. So the body starts not from t is equal to 0 as observer observes his time, but after some time then the reference clock. So and after that displacement changes. It increases as time passes. Here slope is positive. That means velocity is also positive, because ST graph has slope of ST graph is velocity. That means velocity is positive. That means the body increases its displacement as time passes. Now this graph is straight line. That means v is positive and also constant. That means it is nothing but the uniform motion. Have you got my point? Now the third situation is body is at rest when observer time is 0. That means there is no delay in observer time or reference clock. So the body starts at rest. Here also body does not have initial velocity 0, because the velocity is positive. That means not 0, greater than 0, and that's why, and in the whole journey velocity is constant, that's why it is not zero. So the initial velocity and final here is same because it is constant but not zero. But here body starts at rest or initial speed is zero, and it increases its speed as time passes. The slope is positive, that's why acceleration is also positive, and it is a straight line graph, that's why A is constant in the whole journey. And so it is uniform accelerated motion. Have got my point? I think you have got my point. Now I give you the graph having negative slope. So here there are three graphs which have negative slope because all have obtuse angle with x-axis. That's why its slope is negative. And negative slope means decreases. It gives the decreasing value. So here is ST graph, and when t is equal to 0, there is some position, some displacement of the body. When time passes, its position or displacement changes or decreases, and after some time it becomes 0. That means you can say it happens only when the velocity is negative. Or here slope of ST graph is negative, that's why velocity is negative. And it is a straight line graph, that's why velocity is constant. What does it mean? That the direction of velocity is opposite than the motion of the body. That's why its displacement becomes decreased, and after some time it becomes the body comes at the same position as he starts his journey. Now, so this also gives the uniform motion. This kind of motion is also uniform motion because v is constant, whether they are in opposite direction or not, it doesn't matter. Now in this situation I have told you the observer delayed the reference time. Observer wants the time of the motion from 2 o'clock, but due to the delay in the motion of the body, it counts from 2:30 or to 5 minutes to 2 hour 5 minutes. After that, then we say that the situation is here, and all the information is like similarly as we have given in ST graph. That means here at some time, after some time, it acquired the maximum speed, and after it decreases speed until it becomes 0. So here acceleration is negative because slope is negative, and this graph is straight line. That means it's constant, means it is decelerated, or you can say that it is speeding down. That means its speed is decreased, and after some time it becomes 0. That means final velocity is 0, initial velocity is you can say the value, if value is 20, then initial velocity is 20 or anything. Now in this situation, this situation is same as ST graph. The body has some speed when he starts the bike, and after that it decelerated the bike, and the speed decreases as time passes. After some time it becomes 0. That is where acceleration is negative and constant, and it also speeding down, or this is also speeding down, sorry, and this is also uniform accelerated motion. Uniform accelerated motion, and it is also uniform accelerated motion, and it is uniform motion. I already told you. The only difference between these two graphs is the time of reference close is delayed due to some defect or some situation in the real situation of the body of the motion. A biker may have some work during the time as observer count the time. So it may be train may have blockage in the engine, so some delay is covered. So these are the situation we encounter in the real world. But what happens when in the single graph there are more than one slope? So here I give you some situation in which there are more than or more than two kind of slope. In the first graph, slope is positive for some time and the slope is negative for some time. This means the velocity increases, the body starts from rest and the velocity increases. That means with constant acceleration, because here slope is positive and if this is straight line, that's why acceleration is constant and positive. That's why it is speeding up for some time with constant acceleration, means it is uniform accelerated motion. And after that, when it reaches at maximum velocity or speed, it decreases its speed or declares the motion with constant rate and becomes zero after some time. This situation is same as when the train starts from one junction and reach to the another junction. Now in this situation, the velocity decreases because slope is negative, slope is negative. That means v is negative, but constant. Here displacement it decreases as time passes, and when and after some time when the displacement is zero, the body again starts its motion and the displacement increases as time passes. Here v is positive because slope is positive, and here v is negative. Now in this situation, if you observe the train, then from the junction when he starts the motion, it increases the speed, and after some time between the junctions, it keep the speed of the train constant. So after some time the speed of the body constant, and then it decrease the speed so that it reach to the another station. This is the situation we encounter in the real world. That means here accelerated motion and uniform motion, and that here is decelerated motion with A is negative. Now in this situation, it is very interesting situation that this is as time passes, velocity increases from a start from zero, and then when he got the maximum speed, it decreases its speed at till this time in the same direction because it is above the time axis. But this graph is below the time axis. That means the direction is reversed, and the velocity is increased again in that direction. Have you got my point? Means above the time axis, direction is same, whether the graph whether it's so decreasing or increasing, no matter, but the direction is same above the time axis. But below the time axis, direction is reversed. So here you can see here in the opposite direction or reverse direction, its speed is increases from 0 to some value. Have you got my point? This is the thing that you must have to know about it, so that you must be skilled in kinematics. And the last point I am giving you, how can you compare two graphs when it is plotted on the single coordinate axis. So here I am plotting two situations on the same coordinate axis. The motion of body A and motion of body B, and I have plotted ST graph for the two cases. So if I want to ask you that which have the more velocity than other. So obviously you can say that B is slower than A, or A is faster than B. Why? Because its angle is larger, and that's why its slope is greater. Means if theta is large, that means tan theta is also large. That means slope is large, or it has more value. That's why ST graph, slope of ST graph gives velocity. That means it's large. That's why for A it is large. That means A is faster than B in this case. Have you got my point? Now in the same way, I can see here that the motion of the body here, body A and B, you can see at this point the displacement is same for both the body at this time. Let's say it is 2 seconds. After 2 seconds, the same displacement is covered by body A and B, but after below this 2 seconds, the body B covers the displacement, and the body A covered the displacement with different rate, and after 2 seconds it also gives cover the displacement with different rate. That means slope is different. Here this angle is greater than this. That's why the slope of ST graph for A is large. That means slope is large. That means its velocity is large. That's why it changes its displacement swiftly than the body B. So, but the only difference between A and B is that here it starts from rest or zero position. It also starts from rest or zero position, but it delayed the time, but the motion of B is start from 0. Means if an observer has a clock and it counts the motion of the two bodies from 2 o'clock, then B started from 2 o'clock, but A started after some time from 2 o'clock. This is the difference. But the A is faster than B in this situation. Now in this case, slope is negative for both the body, but the rate at which it decreases is higher in what? Here the angle is larger, here the angle is smaller. That means we can say that it decreases speed very swiftly or very fastly, but it decreases its speed very slowly. That means the body B comes at rest in larger time than the body A. So here you see that at this time body B is at rest, but in a short time body A is at rest, because its rate or slope is larger than B. That means it changes its velocity, its speed very swiftly as compared to B. Have you got my point? These are the things you must encounter in kinematics. So you have to practice all the graphs very carefully and understand what are the information hidden in the graph. And after picking some problems, numerical as well as conceptual, you will be trained in the graph. So in the next lecture, I will give you more about graph, or I also give you the idea about how the area represents some interesting facts in the graph. So till then, stay with me and learn kinematics. Thank you.